So this week I was busy at the Artificial Life 2026 conference. So it was a pretty big deal. I'll talk about the presentations that I gave there. And so let's get started. So Artificial Life 2026, this was hosted by the University of Waterloo in Ontario, Canada. So this is the campus of Waterloo. Um, and it's a tech college. It's kind of like Stanford or University of Illinois Urbana-Champaign, or even something like MIT, where they produce a lot of people, a lot of computer programmers, a lot of people in engineering. And it's it's the main engineering university in Canada. So they produce a lot of programmers and other people like that for tech companies. And we'll talk about a tech company that they kind of gave a shout out to during the conference in a bit here. So the conference was on. It's a city, Kitchener Waterloo. Waterloo is where this campus is, University of Waterloo. There's also Wilfrid Laurier University, which is right next door. I don't know if it's in Kitchener or Waterloo, but it's basically a sister institution. And so that brings up the way this conference was hosted. So it was hosted virtually, but also physically in Kitchener Waterloo. And they had this, it wasn't just Alife, it was actually a joint meeting between Alife and the AMMCS, which is a mathematics conference. So they had these joint sessions, they had individual sessions, and it kind of went between the University of Waterloo and the Wilfrid Laurier University campus. So these buildings in these different campuses, um, and so there was a lot of content that was related to artificial life, but there were also a lot of different sessions that related to like applied mathematics and modeling and computation science and things like that. So it's nice that they had these joint sessions, this joint interest, and it did deviate a bit from like the more traditional artificial life sessions, especially some of the keynotes. And as I think it was pretty good. I thought it was a pretty good conference. Pretty long. It lasted. They had sessions from Monday to Friday, and it was a mix of different workshops and different main sessions. And so there were a lot of things on collective behavior. There were a lot of things on cellular automata. Um, there were a lot of things on genetic algorithms, and a lot of things on kind of machine learning and integrating machine learning with all of that. So there's some really interesting talks, and even things like active inference were represented there. So it was a very nice conference, and I'm going to give a more detailed presentation a little bit later on, so we can kind of think about, and I have to digest everything. I was actually keeping a slideshow. It's a different version of this slideshow where I was taking notes and kind of making slides as the talks were going on and thinking about next year, thinking about things we can take away from the conference, even doing some agentive coding during the day to kind of work out some ideas. So it's very very exciting and fertile time. On the first day, Monday, they had some sessions, and at the end of Monday, they had a showing of this film. It's called Blackberry, and there's still a company in Kitchener Waterloo called Research in Motion, and they were actually the people who created the BlackBerry. So if you're old enough to remember, the BlackBerry was one of the big PDA devices, or personal digital assistant devices, and they started building those in the late 90s, and they continued to be popular throughout the 2000s and really up until the iPhone came out. So before the iPhone came out, the BlackBerry was the dominant thing that people used for that sort of thing. And so they talked about Research in Motion and how that came to be. And this is a film. It's kind of like a drama, but also a comedy, kind of a dramedy about the founding of the company and about some of the shenanigans involved in it. So, it was Glenn Howerton was in it, so it wasn't that serious. But yeah, it's a nice little social event there. I was responsible for producing two artifacts for the conference. Um, there's this paper, Phylogenetically Mixed Architectures, the Development and Evolution of Agentive Complexity. This is something that I presented in this Saturday meeting before, and I'd worked on. This is agentive coding of a pipeline that has a bunch of different computational models in it that allows you to build an agent population of, or generate that agent population, evolve different shape combinations, and then put together different components into a common framework. So I'll talk about that in a minute, the rationale for that. But it is related to what we were doing with developmental brain vehicles. And it is sort of like a takeoff on that, but it's also relevant to other different projects that we're doing. So I'm kind of excited about it. It's not, it's like kind of a first pass approximation at what this pipeline could be. But just kind of laying out the different methods that you could use and, how effective they are. And then there's this whole agentive coding aspect where you're asking the model, or you're asking your agent model to produce code to implement a model. You're working through that model, you're putting it into the pipeline, you're evaluating what the model is doing, and then you're kind of reporting that out. So it's kind of a different way of doing modeling and simulation. Um, and so I have some videos on the YouTube channel. I have an overview of the poster presentation, which is like 20 minutes long, and a more in-depth talk where I have slides, and that's about an hour long. So I think I've kind of beaten that to death in terms of the description. There's also a conference paper that was in the proceedings on this. So that's the formal write-up. Then I also presented at the Life Deaf workshop. So there, like I said, there were poster presentations, there were topical session presentations, and then there were workshops that different people hosted. One of which was this Life Deaf workshop. This was on Tuesday, and I presented ensemble models of early life. So this is work that is, so this was something that Richard Gordon was interested in. And we did a paper on this back in 2024 with Bashir Ahmad. And then Richard and Hussein did a paper on early life as well in 2026. I think it was this year that they published it. So I presented on all that work sort of in a very superficial manner. It was like I had 10 minutes to do it, but people got to see that work. So that was the presentation there.
Yep, yeah. So that was our paper on cold selective topological bias of origins of life.
Yeah.
Which, yep, yeah, in which we performed. I even did some GPU simulations on my video PC. That was really exciting. And I had to explain to Dr. Gordon what a GPU was. So that was
Yeah. Yeah. Well, anyways, I think that like putting that together in its totality is really interesting, seeing where, hold on. So I think putting that together in its totality is really interesting because I think there's a lot of stuff that can be done in the future on that. So the first thing, so this paper here, this first one, Phylogenetically Mixed Architectures, basically this is the idea that you have agents um, that you can design kind of the primitives for. So like for a Bratenberg vehicle, it would be the sensors, the effectors, the connections between sensors, effectors, the interneurons. So sometimes you have interneuronal points within the agent, and then the agent body parts. And the idea is you have this group of parts that you generate through some model. Another model will evaluate the viable combinations of those, and then you go through to a genetic algorithm, and you have the genetic algorithm select the most viable, not just the most viable phenotypes, but the most viable phenotypes that can build sort of an improving lineage. So, if you have a bunch of vehicles that are kind of related through this common ancestry of parts, then you have these lineages that get built. And then at the end of that process, you can take the things that are selected for, and you have different criterion for selection. And you can then put them together in different sort of mosaic architectures. So the shorthand of this is if I had, say, like the tree of life, and I had different taxa in the tree of life. Here we have uh, uh, nematodes, fruit flies, mouse, and a primate. And so we have that, and they're pretty phylogenetically distant. And if we want to take like their bodies and brains and their behaviors, it's a wide range of behaviors. But let's say we wanted to create an agent that combines sort of the architecture or the behaviors of a fruit fly, a nematode, a mouse. So all those three taxa, and remember they're widely divergent in terms of their specializations, in terms of their neural architectures, in terms of their behaviors. But let's say if we wanted to create an agent that was maybe specialized in these different types of specialized behaviors, but also you were able to sort of build an all-purpose agent that could do all these things in one agent. And so the idea would be that we would evolve we'd evolve a bunch of agents, we'd put them together with identified lineages, and then we'd take the lineages and we'd combine them into a single architecture. So that's what we're doing. We're evolving things from a common ancestor, a simple motif, and then we're stitching phylogenetically distant motifs together. And this is the pipeline. So to do this, I propose that we use this sort of process where we create a bunch of variation. So we can do this in a couple of ways. We can do this using a reservoir network, or we can use this using a diffusion process. And of course, a diffusion process in the sense of machine learning diffusion, not physics diffusion per se. And so we have maybe something like Bratenberg vehicles parts list, or in the paper I also used a set of simple shapes to demonstrate the idea. And so this is just kind of a first pass. If we were going to actually put this into production, we might create a more formal input data set of components of different types of sensory motor embodied agents. And then we put them into these different, put them into this pipeline and end up with some lineages of these agents, first of all, and then being able to stitch together architectures from the outcomes of generating variation and then evolving it using
Hey Bradley,
artificial algorithm.
could you just explain what exactly a stitch is?
Oh, I just mean like combining them. You'll see what I mean later with we actually use hypergraphs for this, but basically combining them into the same agent. So
Okay.
stitching is a little vague in the sense I'm using a kind of a colloquial term, but basically
And
it's
I'm familiar with terms like recombination, convergence, evolution, but I don't think that's exactly what you're talking about.
no, it's more like just kind of putting it in the same functional context.
Okay, okay.
Yeah. So the first part here is where we take the input data, we put it into either a reservoir network or a diffusion process, and it turns out that each of these types of uh, model, are good for different types of input data. So, if you have very highly variable input data or sort of input data that is ill-defined in terms of its function, then a reservoir network is good. If not, then you can use a diffusion process. It really is up to the user how they want to implement this. And then, of course, once you enter your data set into these networks, you end up with this time series R of t, which then is used as input for this GAN, which is a a model that has both a generator and a discriminator. So you basically create a latent space. You produce candidate latents from this time series that's generated either from the reservoir network or the diffusion process. You then have a discriminator that sort of evaluates the different latents, and it generates shapes that are candidates for a genetic algorithm or a selection function. So for the diffusion process, we have forward and reverse diffusion, which means that we take things, we embed them in noise, and then we try to recover them from noise. And it's supposed to create a more robust training process for the algorithm. In a reservoir network, we're simply putting things into this network, and we're reporting out the current state of the network, and we're producing a time series. And then we're plugging things into this GAN where we generate a latent space. We take things from the latent space that are viable, and then we hand it off to this genetic algorithm that has a selection criterion, two fitness functions, one of them being select the things that are most similar to one another and create a lineage. Another is find things that are, sort of have a creativity criterion where you find things that are novel and then create a lineage from that. And then finally, we can do things like we can create, this figure isn't even in here for some reason. It's not showing up. But this is where we can create these dendrograms that are these phylogenies that basically show the lineages and their novelty score. And so we can take some of the nodes from these lineages and put them together in a hypergraph, which is where we basically arrange these different phenotypes that are generated from the dendrogram and put them together in the same functional context. And what I was going to show you here was, and it's not showing up for some reason, but it's an image of the of different Bratenberg vehicles and how those were evolved and how those form lineages, and then how those lineages were selected and put into a hypergraph. Okay, so that was a little bit about that. And then again, there are two presentations on the YouTube channel, so I'll let you look at those. And then, of course, this is the early life work, so we focused on two things. The first was compartmentalization, which is where you have this idea of concentrating things into containers, which is thought to be one of the hallmarks of early life. So a lot of early life work is done in vesicles. And so, the idea is that you have these vesicles where biochemical reactions can happen. And the idea is if you have, vesicles are sort of the earliest cells, that things, you have reactions that have to occur in a confined space in order for them to be protected from the environment, in order for them to sort of be concentrated in a meaningful way. And then, you can have something that resembles a cell, and then, what people will do is they'll create these vesicles experimentally, which are basically lipid membranes with things inside them, create something that will kickstart reactions, and then, eventually you can have cells, and you have vesicles that can divide and reproduce, and then that's basically the start of life. So compartmentalization is an important part of early life, and also evolvability. So it's like, how do you put the parts of these very simple components together to form complex phenotypes? Okay, so so then that's what the early life presentation was on. This was the initial work that Richard Gordon, myself, and Bashir Ahmad did in 2024. This is where we did a number of simulations on this idea of compartmentalization, having these vesicles where things kind of moved in and out of the vesicles, and then reporting on sort of what happens when, with vesicles of different sizes and of different densities of mixtures within them. And so that was the paper. I talked a little bit about that paper and some of the results. And then this is work that Hussein and Richard Gordon did. And this is where they kind of, instead of assuming that this was sort of a homogeneous membrane, then you have these more complex membranes that are these trapezoids with a polar head and hydrophobic tail. So you're adding in biological detail, you're adding in this heterogeneity, and things that disrupt, importantly, things that disrupt symmetry and introduce topological variation. And so this is just kind of thinking through this aspect of the work. There's also, of course, this work on evolvability, which is tied to the phylogenetically mixed architectures in the sense that you're creating from a parts list these lineages, these phylogenies of things. And the idea is like, can we create things from a parts list that are viable through some simple recombination process? And can we basically kickstart some sort of phylogeny from that? So yeah, I think the work was, pretty, it's like at any conference you present, I didn't get a lot of feedback, but it's like you continue to work from what you presented. Okay, Hussein.
Yeah, I had a question on that last slide that you had with the two orange dots. What exactly were those?
Which slide was that?
This one, you have it right there.
Okay.
Compartmentalization. What are the orange?
Oh, this is supposed to be a sky. So this is one part of the talk where in the original paper, the first paper, we did this experiment with day-night cycles. And so you'd have like the day and then the night, and then the idea was that for the vesicles, you had these membrane pores that would open and close with day and night. And so you would have an opportunity for the components to escape and an opportunity for the components to diffuse into the membrane. And so when the membrane pores were closed, you could have reactions if the day-night cycle were longer, say. And then when the day-night cycle switched, like I don't remember if it was day or night, when the pores were open, things would diffuse out. So you'd have less of a chance for reactions. And so that was what this was referring to as this sort of day-night cycle in an early planetary environment. It just had this graphic that didn't really mean anything.
It's like sunlight, then nighttime, then sunlight again. Okay.
Yeah. I just used that theme throughout the talk, wasn't it?
Yeah. I'm happy to share my updates on PCC if there's time for that.
Yeah. Would you like to do that now, or? Yeah.
No, I can do it now, unless there's something else we need to talk about, or like if there's something.
Well, Morgan's going to give an update, but yeah.
And I also do need to.
Okay, we'll go. We'll let the others. I think they can.
Okay, well, yeah. Who wants to go first, Morgan or Sarah?
Morgan, you can go first. No. Okay, fine. Okay, so two updates from my side. One is regarding what Jesse said again for the fall. So, I mean, what I understood was we were trying to see if there were projects that we could take up, maybe even stir up some interest in the same. And, So for that, I mean, I do think the kind of the extension of my GSOC 24 project that I had planned this year for 26 that we also had quite some interest on. And so because of those discussions with all those contributors and all of that kind of being documented in those GitHub issues as well, I do think we now have quite a clear roadmap on where we want to go. So, I mean, that is a decision we can take, I guess, on whether we want to kind of sorry, just a second. Yeah, sorry. I just wanted to say on whether you want to kind of keep that for GSOC 27, or I do feel like if we gather enough interest, that is something that I could mentor kind of, even if it's during the fall season, instead of waiting for the summer, where we could have some enhancements on the that we had discussed already for 26 be done. So yeah, that chess is the what I put up in the message as well. So it's mostly software related. It's technical enhancement. So I don't know if that is exactly what you were looking for, but
Well, yeah, I mean, and is this when you said put in the message? Did you mean in Slack or?
in the Slack, yeah, this is what I'm talking about, the Slack thread. When you talked about things for the fall, should I bring it up?
Oh, I see. Yeah. Okay. Um. Yeah. I mean, it really depends, and I don't know. I defer to Bradley about this too, but like, if it's something that you want to work on during the fall, like, and would want us to work on either with you or like center more, like, absolutely. Like, if it's you don't have to wait until summer to work on it if it's something you want to do.
Hmm.
And if you want, you can work on it just yourself, or if you want there to be more like, hey, here's something that we're going to try to do and center a bit more.
Okay,
That's
the
I guess
audio
my
did cut
take
out.
on it. But, yeah.
Okay.
Yeah.
Yeah,
I think
but
the
I mean,
advantage
so
of
like, sorry,
the
Bradley, go ahead.
advantage of doing this in the fall is where you don't have the pressure of GSOC, so people can work on it.
Hmm.
Can want to work out some of the things about the issues in that too. So.
Yeah, so I think then for fall we take up the guardrails and the issues and all of that, and because this is something that could easily be worked on by a new contributor or a student as well.
Yeah.
So I think we can defer this to summer then maybe. I wasn't sure what call for involvement meant. I mean, if it was us working or if we wanted something that would be appealing to first time contributors. So this I would definitely classify as something that's more appealing to first time contributors. So I mean we can try to maybe then take it up in the summer and try to work on the guardrails and how we can, structure our repository more in the fall. So I will try to look into that as well, the links and everything I sent today, and what kind of policies we can make, all of that.
Yeah,
Uh,
and in general about that, like in terms of call for a moment or what you want to do, like we can talk about it more here or offline or in Slack or whatever. But like however you want to, the call for a moment in general, because it seems to have raised a lot of questions, is basically like an open call. Like if people want to say, hey, here's a project that you can take some leadership in during the fall, like it's sort of just saying,
hmm.
let's build it out, and if you want to do it or like get help, if you want someone to join the projects or whatever, like let's formally, it's sort of
Hmm.
it's administratively sort of working with you to do that, because a lot of times these things will happen or they'll fall off the map and they'll be whatever, then I'm interested in this stuff, but it's like this is a very intentional overt gesture of Bradley and I are open to building out or supporting, offering administrative support for the project if you want to do the leadership. The thing we can't supply is the leadership and the desire to make the thing happen. That's on you
Right.
at the level you want
Right.
to do it. But like outside of that, we have the means to, we're in this sort of, it is the time to let people know you want to work on
Kind of
this.
expand.
Yeah, expand or make it a lot of this stuff. We in this room and in this, if you've been here with us, you know what Sarah means. You know what Asha did. You know what Barshan did. Like you know what the people have been working on this summer or in this thing or in that stuff. But anybody outside of this room probably has no idea. So it's the work
Yeah.
of creating a organizational structure or space that other people can see it and say, okay, oh yeah, Sarah has this project. Oh, what is it? Where do I look at it? How can I do it? And maybe we can have like a small you know, like not every project requires to have an internship or a call for other people to work on it. But if you do want that, we're like, well, we'll help you do that. That's kind of what I was getting at with all those things.
Okay. Yeah, okay, I get it. I get it. Yeah, okay, then, I mean, so again, the reason I kind of, I mean, so just from my perspective, I was thinking of kind of mention this to Bradley as well, but I'm going to try to be applying for a master's in fall 27. So
Yeah.
the application process for that would kind of start, now for me,
Yeah.
with like the test of English as a foreign language, and then everything else just will like a one by one. After that, my GRE is done, so that I'm good with. But everything else is kind of to do for me. So yeah, again, I mean, I'm not just sure about how much time I will have. So that is why I felt like leadership is something I could have. But yeah, I mean, individual contribution, especially if you're also trying to do the guardrails and everything. But I can still look at it. What I can do, I guess, is so I do have some connections from my college, right? So let me kind of see if there would be, maybe students who would kind of be interested in contributing to this. And then
Yeah.
if we do have interest, and then, I could then definitely take up leadership and mentorship in a sense.
Yeah, and like you can obviously just, I know you know this, but like you don't need to do all that extra stuff too. We're just offering it as like a thing. So whatever form and whatever whatever capacity you have, it's just like I think that'd be, if you have the means to do the other stuff, that's great too. And also, like, I'm sure we're all happy to, good luck on the master's application anytime you want to talk about that. You
Yes.
say you were applying to specific places like outside
I
of?
have not yet. Yeah, I mean, it will definitely be outside of India.
Yeah.
And I do want US to be a major focus. I might apply somewhere else as well. I mean, I'm still a little bit on the research side of everything. But yeah, I mean, I will, keep you all posted, and also
Yeah.
I think keep coming to you all for advice a bit as well. But
Sounds
yeah,
good.
not yet fully decided on everything. But I mean, I will definitely be applying to some US codes for sure.
Okay. Well, definitely stay in touch about all of that, and I'm happy to see you do that, and also like I think you bring up a lot of things, and even the email, which I'll say more about that too, but like I think you've got a lot of good things that I hope you keep going towards.
Yeah.
So,
Yeah, same. Yeah, okay. So that's one thing. I think, yeah, just let me float out and see if there's interest, and then I'll get back to you, and maybe offline, or just I'll ping you on Slack, and we can see about the fall, about trying to do the LM project in fall. Yeah, okay, just give me like 2 minutes. Morgan, if you want to go with a short update, I will just need 2 minutes to try to present for the next thing. I mean, I know you wanted to speak, so if you're ready now.
I can just say a few things. So one, can you hear me okay? Just because.
Oh yeah.
Okay. Yeah. I'm running Fedora on an old iMac.
Okay.
And yeah, so just working through a few glitches. So yeah, this week was the opening of the lab space that you see behind me. So this is the Other Minds lab, and let me just. I mean, this is just a temporary website describing Other Minds, and this is together with two others, Caleb and Skylar. Caleb is a postdoc at starting a postdoc at JPL, in kind of end of September. And so he's a planetary geologist, but is also interested in SETI and, of course, astrobiology. And Skylar's the one who approached me about the supporting kind of the neuro program in terms of both equipment and research mentorship. And in particular, and for both of these kinds of projects, also getting access to supercomputing resources. So like the Neuroscience Gateway being the kind of the neuro version of this. And then Open Science Grid and Globus, et cetera, those kinds of resources that that I certainly became aware of through kind of NanoHub and material science. Both cases, yeah, so access to kind of GPUs, compute to work on very large data sets, right? So astronomy is actually, I think, a great field to really learn from, especially around the topic of physics-informed neural networks, how to accelerate both data processing as well as simulations, because they literally work with astronomical amounts of data. Just to related to that, new paper, or at least new to me, is this from Karniadakis. Yeah, never actually heard it out loud. But this comes back to this issue of so I don't know if you guys remember talking about this particular researcher who's kind of credited with starting PINs and but multi-agent development for these kinds of algorithmic development. Yeah, and this is anyway. I've posted on this. I forget if I've dropped this in Slack already, but like really interesting topic that again, I think we're going to be able to have some nice data sets from other minds lab work that will be really interesting to apply these kinds of techniques as examples, or kind of to prototype things. Yeah. Sort of related, or at least another benchmark is Steve Brunton, who's the very very popular videos on PDEs, optimization, and other topics. Released this Hydrogym, which again is just a nice way for us to test out some of these developments that we're kind of using agentic tools to develop, but really important to have some evaluation for these. And that's those are the big updates here. Sorry, let me turn that off again. There's neuroimaging, and still share the link for yes, Jess, which for other minds. Okay, it is a placeholder. I'd like it to be more like the new Neurotech X site, where it's just like we're doing more. The website is a better is a resource, you know. So, but you know, what I love, Bradley, and certainly what I mentioned was that, like, you know, at our open house on Tuesday evening, that, you know, I think artificial life, you know, the kind of like introspection work in large language models, algorithmic information theory for, you know, learning about structure of messages, are all under the same lab portfolio, or, you know, lab mission, and that also includes origin of life, or like at least some. You know, I talked a little bit about the Build a Cell seminar, which has been really valuable in terms of getting, you know, it's just this wonderful seminar series every Monday to learn about, you know, protocells and membrane physics and, you know, all sorts of replicator replication systems, you know, that, you know, which is led by Kate Adamala, and, you know, who had the recent spud cell paper. So yeah, so I've got a new donation of another Opentrons and some and actually some really nice factory arms, some new factory arms, which I thought, you know, again, well, we've also been doing the last prep work for the how to biomanufacture almost anything, and even though it's definitely got a bit of a practical focus, you know, I like that the node at William and Mary, the professor there is coming up with a practical lab experiment on biofilms that, again, I think some of these experiments are actually, you know, with slight modifications, can actually really be relevant to the same kind of work. The same kind of origin of life, or, you know, interesting physics properties that like CompuCell 3D people kind of care about, you know, for thinking about, you know, interactions and yeah. That was our week.